In this video, we are going to look at another example of solving triangles that are in the ambiguous case. So here we are, we have an example 2 over here. Triangle DEF is given. We have an angle D that's obtuse. It's more than 90 degrees. The side that's opposite of it is 50 centimeters, and the other given side is 20 centimeters. So we're told that we need to solve this triangle. So step 1, since we can see that we have two sides and an angle, we're going to check to see if we have more than one triangle. So step 1 is to check. So our opposite side is 50 centimeters, and that's bigger than the given side. Right? Our opposite side is bigger than our given side. And if we remember, in the last video, we looked at 3 different cases, and we saw that if the opposite side is bigger than the given side, well, then there's only one triangle that is possible, right? So that means we only have one triangle that we need to draw and that we need to solve. So there's only one triangle that can exist. So now that we know that, we can start drawing that triangle. So I'm going to draw a triangle. I know it has an obtuse angle. I'm not drawing that very well. Let's try again. So I'm drawing my triangle. I know I have an obtuse angle, and I know my opposite side is 50 centimeters. Whoa. My shape's looking weird. 50 centimeters, and this is angle D, which is 130 degrees. And then I know that angle E, let's say that this corner was E, I know that this side is 20 centimeters, right? So what I don't know is F, angle F, or side F. So if I'm trying to find this, I'm going to want to use sine law because I have an opposite angle and side, right? So I'm going to say the sine of 130 divided by 50 centimeters is equal to the sine of F. Oh, I can't do F yet, right? So if I was trying to find F here, well, I don't know what side F is, and I don't know what angle F is, so I can't really do this one yet. But I do have a side solved for E, so that seems to be the only one I can really solve right now using sine law. So I'm going to try and solve for angle E here. So the sine of E divided by its opposite side, which is 20 centimeters. So if I'm trying to find angle E, I'm going to bring the 20 up, so I have angle E is going to equal the inverse sine of 20 centimeters times the sine of 130 divided by 50 centimeters. So when I plug all of this into my calculator, I'm going to say the inverse sine of 20 sine 130 divided by 50 equals, turns out it equals 17.8435 degrees, right? I'm going to round this to the nearest degree here and just say that's equal to 18 degrees. So now that I have angle E, I can find angle F. Angle F is going to be 180 minus 130 minus 18 degrees. So 180 minus 130 minus 18. Well, angle F, the one that's left over, is 32 degrees. So now that I know E is 18, and I know that F is 32, well, I can also solve for little side f, because now I have at least one part of this angle side pair. So I'm going to go ahead and do that. So I've got the sine, well, actually let's solve for f. So I'm going to put f on top. So f over the sine of its opposite side is equal to 50 over the sine of its opposite side. So f equals sine of 32 times 50 divided by 130. Oh, make sure that you actually write out the whole sine of 130, because sometimes I see students writing just 50 over 130 and they forget the sine part, and then they get it wrong. So make sure you're not one of those people. So we're going to do 50 times the sine of 32, and we're dividing it by the sine of 130. So you'll get that side is equal to 34.5880, etc. And if I'm going to round that to one decimal place, I would round that to 34.6 centimeters. So now I know that f is equal to 34.6 centimeters, and there is nothing left to solve on that triangle.